Steel and concrete are strong, but does that mean your building is safe? Think again. Strength on paper is not safety in practice. What matters is how loads flow, how details connect, and how well it's built. Most people assume using the strongest materials guarantees safety. High-grade steel, premium concrete, thick walls. They all sound reassuring, but materials are only one part of a safe structure. Design, detailing, and supervision tie it all together. In reality, poor design can make even the strongest materials fail. Discontinuous load paths, missing shear walls, and weak connections create hidden failure points. A slab can punch through a column even with 40 megapascals concrete if the joint is underdesigned. Strong beams with weak columns lead to story mechanisms and catastrophic drift. Take, for example, real cases of building failures caused by bad design, not weak materials. Common red flags: inadequate column shear, poor detailing, and re-entrant corner stress risers. Soft story layouts, often open parking at ground, create weak first floors that can collapse in earthquakes. Balcony and slab edge failures frequently trace back to insufficient waterproofing and rebar cover causing corrosion. Differential settlement from poor geotechnical investigation can overstress even well-made elements. Missing seismic confinement, short lap splices at plastic hinges, or inadequate development length can undermine otherwise strong materials. Across incidents, the pattern is consistent. Where details are weak, materials alone cannot save the structure. Engineers balance load paths, soil conditions, and design, not just materials. Every load must have a continuous ductile path to the ground, with redundancy. Soil reports dictate footing sizes, piles, or rafts. Ignoring subsurface conditions invites settlement. Lateral systems, shear walls, braced frames, moment frames, control sway and seismic performance. Detailing matters. Hook angles, cover, anchorage, and development length prevent brittle failures. Execution matters too. Inspection, testing, and tolerances ensure the design intent is realized in steel and concrete. The truth is, strength comes from proper design plus execution, not size or strength alone. Continuity, ductility, and quality control outperform oversized but poorly detailed work. Following modern codes, using peer review where needed, and testing materials closes the safety loop. Curing, compaction, and inspection convert specified strength into real performance. A well-designed building feels calm, predictable creaks, controlled vibrations, and no alarming noises. If you're a property owner, always hire qualified engineers, not just builders. Ask for stamped drawings, site inspections, and test reports. Concrete cylinders, weld NDT, rebar cover checks. Hear strange noises? Document time and location, then consult a structural or MF engineer. Most noises are harmless. Thermal movement, HVAC, plumbing, but persistent or abrupt changes warrant evaluation. Stronger buildings come from smart engineering. Subscribe for more myths busted.